Okay, in class, question 8 was causing people a little bit of grief, probably because there's two unknowns, A and B. So the difficulty is increasing here. We've got a curve y equals a square root x plus b divides square root x. A and b are just numbers. Constants means they're just some number. The normal to this curve at the point where x equals 4 is 4x plus y equals 22. Find the values of a and b. All right, well, I need to write all this down, so let's start the question. This is 15b, and it's question 8. Okay, so here's the equation. Now, I'm going to write, I want to write the normal equation down as well. So the normal, 4x plus y equals 22. The reason I want to do that is because I can get a gradient from this pretty easily. Y equals minus 4x plus 22. Now that it's in gradient intercept form, as in y equals mx plus c, I can see the gradient of the normal is minus 4. Therefore, the gradient of the tangent, or the gradient of the tangent to this curve, right? It's like the gradient on this curve equals 1/4. And I think that's going to be useful, right? Okay, so x equals 4. We could write what the y value is 2. It'll be a times, let me see if I can undo that. I've ruined my a. There we go. It will be 2a plus b on 2. Okay, because if I put 4 into here, square root 4 is 2, square root 4 is 2. I know what the y value is as well, right? So. This, we can use this together, can't we? Maybe we should do that first. All right, so we know that these x and y values on this point satisfy this equation at x equals 4, right? So we could say, right, using equation of normal. Now I could have started with the derivative because we're going to be using that as well, but we have an x value here, we have a y value, and we have an answer, right, where x equals 4. We have an equation that fits where x equals 4. So we can get an expression using this normal equation. So we could say if y equals minus 4x plus 22, we could say 2a plus b on 2 has to equal minus 4 times 4 plus 22. All right, so 2a plus b on 2, that's minus 16, it's 6, right? Minus 16 plus 22 equals 6. And I think I'm going to need that equation later. I'm going to just give it a little label, equation 1. I'm also going to want the derivative so that I have a second equation. When you've got two unknowns, a and b, you're not going to be able to solve them. You're not going to be able to work out what they are just from one equation. You're going to need two equations, right? Because potentially there's an infinite number of possibilities here. Like if, I don't know, if b's 1, then I'd be plussing a half to get to 6. I could say this part has to be 5.5, but then b could be, I don't know, 4. So there's, an infinite number of possibilities. I need two equations to know to limit what a and b can be. And that's what the derivative will give us. But before I start, let's rewrite it. Let's rewrite the y equals equation into a form that's going to be easier to differentiate. Okay. All right. So now I can apply my power rule a bit easier. Now that I've used indices instead of surds, I could say a half a x to the minus half. Now that'll be minus half comes out the front, so we'll get minus half b x to the minus 3 on 2. And I like to go back into surd form again. I find it easier to use the equation in surd form, although easier to differentiate in index form. So we would get a on 2 square root x minus a half times b x square root x. Okay. I'm going to keep going over here, I think. So at x equals 4, dy dx had to equal a quarter. Now, how did I know all that? Well, because everything's happening at x equals 4, and because from the normal equation, I knew the gradient of the tangent, and it's the derivative that gives me the gradient of the tangent. I've written it here. Gradient of tangent, that should say of, doesn't. Gradient tangent to curve is a quarter. So let's put 4's in here. So we could say therefore dy dx equals a quarter at x equals 4. Why am I rewriting it? Let's just go straight to putting, I've already said all that. Let's just use the equation. Therefore, a on 4. All right, so if x equals 4, square root 4 is 2. 2 times 2, 4. Minus b. All right, what's going to happen here? You've got 2 times 4 is 8. 8 times square root 4, so that's 8 times 2 on 16 equals a quarter. And that can be equation 2. So I now need to solve these things simultaneously. If you're like me, you prefer your favourite method is elimination method, so I think I'll use that. This equation here is full of fractions which I don't like, and I just thinking. I might manipulate both of them actually. So I'm going to rewrite equation 2, but I'm going to times everything by 16. Right, so you get 4a minus b equals 4, right? So I've said that times 4 minus that times 4, sorry, times 16. That times 16, 4a, minus that times 16, just leaves b, equals that times 16 is 4. It's my equation 2. My equation 1, if I want to set it up for elimination, I could do that if I had 4a there. And that would work nicely because it would mean I'd just be left with 1b as well. Yeah, okay. So there's different ways you can deal with this. Simultaneous equations. You even have an app on your calculator that can solve these. But I'm setting this up for an elimination of the a's. I think I'll do by subtracting. I could have eliminated the b's by adding and found a will equal 2. Anyway, there's different ways you can go. I'm going to eliminate the a's, so go 4a minus 4a is 0. Then I'll have minus b minus another b, that's minus 2b, will equal 4 minus 12, which equals minus 8. Therefore, b will have to equal 4. Okay, if b equals 4, now I think a equals 2, but let's substitute it in. So you could say substitute b equals 4 into equation 1, and then therefore you'd have 4a minus 4 equals 4. You'd have 4a equals 8, and you'd have a equals 2. All right. Now, with simultaneous equations, it's always worth checking things. So if I've really done this right, if I substitute into equation 1, oh, I didn't. I substitute into 2 there. If I substitute into 1, I should still get a equals 2. I can check this. I should have 4 times 2 is 8, plus 4 equals 12. Yeah, everything's working. So do some checks, then you'll know 100% that you've got it right. I'm just going to check the question to see if we finished everything. I'm not sure if they want an equation for a tangent or not. Let's have a look. No, it just says find values of a and b, so we are done. All right,